Objective 3. Determine the variance of a variable from raw data. Up to this point, we have studied two measures of dispersion, the range and the standard deviation. A third measure of dispersion is called the variance. The variance of a variable is the square of the standard deviation. The population variance is sigma squared, and the sample variance is s squared. The units of measure in variance are squared values. So if the variable is measured in dollars, the variance is measured in dollars squared. This makes interpreting the variance difficult. For example, determining the variance of a variable from a population and a sample. In previous examples, we considered population data of exam scores in a statistics class. For this data, we computed a population mean of mu, which is equal to 79 points, and a population standard deviation of sigma, which is equal to 9.8 points. Then we obtained a simple random sample of exam scores. For this data, we computed a sample mean of 73.75 points and a sample standard deviation of s, which is equal to 11.3 points. We're going to use the population standard deviation exam score and the sample standard deviation exam score to determine the population and sample variance of scores on a statistics exam. Now again, the population variance is found by squaring the population standard deviation. The sample variance is also found by squaring the sample standard deviation. So, the population standard deviation, of the population was 0.98 points. We know it's 0.9 points. So the population variance is taking this value and then squaring it. So when you square it, then you're going to get 96.04 points squared. Next, we have the sample. So the sample standard deviation from our problem was 11.3 points. So we know S is 11.3. So if we want to find the sample variance, we're going to take that standard deviation and then square it. So when we square it, then we get 127.7 points squared. Now note here, it says be sure to include the units squared when reporting the variance. Now there are some important issues when computing the variance. And so some of the important issues are the following. When we can compute the variance in two ways. One way is to compute the standard deviation first and then squaring the result like we did over here on the left. So for this example, we found that the population standard deviation was 9.8 points. If we square that result, we get a variance of 96.04 points squared. Now the expression under the radical in the formula for the standard deviation is the formula for variance. That is the formula for population variance. And that is the formula for sample variance. So if we work this problem by hand, we would have that the standard deviation was the square root of 96.4. That value on the inside, that is our variance. And if you think about the other way for calculating variance, we got a result of 96.04, which is different than the result that we would obtain by getting 96.4 points, which is exact. Using a rounded value of the standard deviation to obtain the variance results in a round-off error. To deal with this issue, you want to use as many decimal places as possible when using standard deviation to obtain the variance. Now, bias in variance and standard deviation. The sample variance is obtained by using the formula s squared, which is equal to the sum of the data value minus the sample mean squared over n minus 1. Now, what if we divided by n instead of n minus 1 to obtain the sample variance as one might expect? Well, then the sample variance would consistently underestimate the population variance. Whenever a statistic consistently underestimates a parameter, it is said to be biased. To obtain an unbiased estimate of the population variance, you divide the sum of the squared deviations about the sample mean by n minus 1. To help understand the concept of a biased estimator, consider the following scenario. Suppose you work for a carnival, guessing people's ages. After 20 people have come to your booth, you notice that you have a tendency to underestimate people's ages or guess too low. What could you do to correct this? you could adjust your guesses higher or to avoid underestimating. So in other words, originally your guesses were biased. To remove the bias, you increase your guesses. This is what dividing by n-1 in the sample variance formula accomplishes. Unfortunately, the sample standard deviation given by the formula here, S, which is equal to the square root of the sum of x subscript I minus the sample mean squared over n-1, is not an unbiased estimate of the population standard deviation. In fact, it is not possible to provide an unbiased estimator of the population standard deviation for all distributions. The explanation is beyond the scope of the class. It has to do with the shape of the square root function. However, for the applications in this text, the bias is minor and does not impact the results.